Alright guys, this will be the first progress check of Unit 5. So following along with the first question, it is a calculator required one, but it says let f be the function given by f of x equals cosine of x squared plus x plus 2. So f of x is equal to cosine of x squared plus x plus 2. And the derivative of f is given by f prime of x is equal to negative 2x plus 1 times by sine of x squared plus x. What value of c satisfies the conclusion of the mean value theorem applied on the interval from 1 to 2? So let's follow through with the math kind of procedural part of the mean value theorem. They give us the interval from 1 to 2. And so I'm going to find the average rate of change on that interval. So we're going to find f of 2. F of 2. So if you have your calculator, you can plug this in. But it's going to be cosine of, that's going to be 2 squared is 4. 4 plus 2 is 6. So cosine of 6 plus 2. And so that's going to be cosine of 6 plus 2. And I have 2.960. Okay, and then f of 1, which is going to be cosine of 2 plus 2. So cosine 2 plus 2. And I got 1.584. As for the average rate of change, so let's do that. So f of 2 minus f of 1 over 2 minus 1. So let's do that right there. So I'm going to take f of 2, which I have there, and I'm going to subtract f of 1, subtract those together, and I got 1.376 as the average rate of change, and then it'll be divided by 1, so that's not going to change that part right there. Okay, I'm looking at the answers right now. Okay, so that's the average rate of change, and it's asking us what value of c. So the c value they're referring to is the number in between 1 and 2. So what's the number in between 1 and 2 where f prime is going to be equal to this right here? So I think we're going to graph this right here, and we're going to set it equal to this value right here. Okay, so let me go ahead and go to my graph right here. We'll go y equals, okay, so we're going to graph f prime of x, so that's going to be negative. We have 2x plus 1, and then we have sine of x squared plus x. And then we're also going to input the value of 1.376. I'm going to put in a couple more decimals in there. 317. Okay. And let's see. We're talking about the interval from 1 to 2. So that should be a good enough interval right there. So the interval from, I'm actually going to do the interval from 1 to 2. Okay, and then I can see where they're equal to each other. So if I go trace that, so the intersection, so here, enter, and I got 1.438, which is what we have as our answer. So we can say that f prime of x is equal to 1.376 at x equals 1.438. That's the value of c that they're referring to. This value of c is in this interval right here, and it's where the average rate of change is going to be equal to the instantaneous rate of change. So that is going to be B. All right. the next question, we see the derivative of the function f. This is also calculator required. So we're given f prime of x is equal to the square root of x times by sine of 3 root x, okay, on which of the following intervals, so from 0 to 6 pi, is f decreasing? Okay, so f is decreasing when f prime of x is negative. So we're going to graph this right here on this interval and see where it's negative. So back here, we're graphing the square root of x, and then we're going to do sine of 3 root x. And for my window, we're going to do from 0 to 6 pi. Graph it. And okay, so we're looking for, there's two intervals where f prime is below the x-axis. So I am just gonna see if I can, so I know this, I mean, I could be more accurate. I can go to trace and I can go to option 2 for the 0, do left of that 0 and do right of that 0. I got 1.06, 1.06. So I can see that options A and C have those as the options. But okay, so the difference between A and C is that A, if you're looking at your options, A has 3 intervals, but if we're looking at this graph, there's only 2 intervals where f prime is below the x-axis. So I'm just going to go ahead and pull the trigger, and this has got to be C. It's kind of a quick response, but I can just see from my choices that that's going to be the case, and then I can scroll over here to the other x-intercept and kind of give a guess, but 4.3, yeah, that looks about what the interval is saying in the answer. So yep, I think we're good there. Alright, for 3, let f be the function given by f of x equals x squared minus 9 over sine of x. So f of x is equal to x squared minus 9 over sine of x on the interval from 0 to 5. Okay, which can the mean value theorem be applied? So now, so what we're going to do here, because the mean value theorem, the conditions of the mean value theorem are that the function has to be on a closed interval and it has to be differentiable and or continuous and differentiable. So I'm going to see right here, let's define where this function is not continuous. And so that's whenever sine of x is equal to 0. Sine of x is equal to 0 when x is equal to 0 itself, pi, and 2 pi, but 2 pi is not in this interval right here. I guess I should make that look more like brackets. So when x is equal to 0 and when x is equal to pi. So that's where this, so if we were to kind of look at this, think about this graph right here and draw a number line based off of its, so we're talking about the interval from 0 to 5. So at x equals 0, it's undefined, and at pi, it's also undefined. So let's look at our option. So option number 1, so it says between 1 and 3. So between x equals 1 and 3. So that would be, that interval would be continuous because we're not including 0 and 1. So 1 is true. So we can use 1. And then if we look at 2, so 2 says between 4 and 5. 4 and 5. And we are continuous on that. And so 2 is true. And as for 3, between 1 and 4, no, we're not continuous because we're undefined right there. So that's a no. So it's got to be option C, 1 and 2 only. Alright, so for 4, let f be a differentiable function with f of negative 3. So we have f of negative 3 is equal to 7, and we have f of 3 is equal to 8. Which of the following must be true for some c in the interval? So we have some options that are talking about the extreme value theorem, mean value theorem, and the intermediate value theorem. I'm going to take a guess that it's going to be mean value theorem, since that's what we're talking about in this unit. So maybe B or C. But let's review what the extreme value theorem says. So basically, let's say this right here. So if we kind of graph these points right here. So say that we graph f of negative 3, it's said to be, we'll call this 7, and then f of 3 is said to be 8. Okay, and so right here, what the intermediate value theorem says is that if we are continuous on this interval, then we have to take on every value between 7 and 8. So f, and it has nothing to do with the derivative, so it can't be D. The intermediate value theorem has nothing to do with f prime. The extreme value theorem says that on a closed interval, and if it's continuous, then there's guaranteed to be a max and a min on that interval. It has nothing to do with the derivative, so it's not going to be A. Alright, so as far as the mean value theorem, the mean value theorem says that the average rate of change will be equal to the instantaneous rate of change on that interval if it's differentiable, which it is. And so we're saying that 8 minus 7 over 3 minus negative 3, which would be equal, so it doesn't really matter what that's going to be equal to, but there is going to be a value in between there where f prime of c, so there's some value in between here where the average rate of change is going to be equal to the instantaneous rate of change, somewhere in there. And so the difference between C and D is that C has the correct notation and B does not, so it's going to be C. Alright, for 5, so we got let f be the function given by f of x equals sine of x, cosine of x. Okay, so let f be the function given there. So f of x is equal to sine of x, cosine of x over x squared minus 4. Okay, on the closed interval from negative 2 pi to 2 pi. On which of the following closed interval is the function guaranteed by the extreme value theorem to have an absolute maximum and an absolute minimum? So the extreme value theorem, the condition for the extreme value theorem is that the function has to be continuous, not differentiable, just continuous. And so we're going to check and see where this is not continuous, and that's going to be at x equals 2 and negative 2. So again, if I set up an interval between negative 2 pi and 2 pi, this is negative 6.28, that's positive 6.28, so we're going to have 0 directly in between them, and we're going to have like negative 2 over here and positive 2 over here. Okay, so let's look at the options that we have. So we are undefined here and here, or the function f of x is undefined here and here. And if we take the interval from negative 2 pi to 2 pi, is there guaranteed to be an absolute min and maximum? No, not guaranteed, because we're not continuous on that interval. And then from -2 to 2, note that it is saying brackets, but no, because we are not defined at -2 and 2. And then it says from -1 to 1. So we are continuous on that interval right there. So yeah, I think it's got to be C. Let's just check D, but it says pi halves. So pi halves would be less than 2. And then to pi, which would be greater than 2. So no, because we're undefined at 2. All right. Question 6. So let f be the function defined given there. Man, what about... Okay, we're getting to... Alright, so f be the function. So we have f of x is equal to x squared plus 1 over x plus 1. And we have a domain 0 to infinity. The function f has no absolute maximum on its domain. Why does this contradict the extreme value theorem? Because this is not closed. So we have a bracket here and an open. So this continues to infinity, which means that we're not closed right there. So the domain of f is not an open interval. Well, it is an open interval, so it's not A. The domain of f is not a closed and bounded interval. Correct, yeah. The function f is not continuous on its domain. It is. So if you think about this right here, x cannot equal -1. And that's not within the domain right here. So not C. It's B, but I'm just checking the other option. So for D, the function f is not differentiable on its domain. I'm pretty sure it is. We probably need to graph it, but I'm pretty sure it's differentiable from 0 to infinity. It should be, yeah. I don't see any reason why it wouldn't be. So yeah, it's got to be B. So the reason, so the function f has no absolute maximum on its domain. Why does this contradict the extreme value theorem? Because this is it's not bounded, it's an open interval. Yeah. Okay. For 7, select values of a continuous function f are given in the table. Which of the following statements could be false? So by the intermediate value theorem, so checking option A. So checking option A, the intermediate, I guess I should say A. The intermediate value theorem applied to f on the interval from 0 to 4. So on the interval from 0 to 4, there is a value c such that f of c is equal to 5. Let's check that. So f of 0 is equal to 2, and f of 4 is equal to 18. Oh, okay, so once I ask you to say that, that's true, but we're looking for what could be false. So on the interval from 0 to 4, we have y values of 2 and 18. So is there going to be a value in between 0 and 4 that will make the function equal to 5? Yes, by the intermediate value theorem, that's true. So that's true. So for B, the mean value theorem applied to f on the interval from 0 to 4, okay, such that f prime of 4, f prime of c is equal to 4. So let's do let's check the average rate of change. So the average rate of change on that interval is going to be 18 minus 2 over 4 minus 0. 18 minus 2 is 16, right? 18 minus 2 over 4 minus 0, 16, and 16 over 4 is going to be equal to 4. By the mean value theorem applied to f, there is a value c such that f prime of c. I want to say that's true. Question mark. Let's check C. So by the extreme value theorem applied to f on the interval from 0 to 4, there is a value c such that f of c is less than or equal to f of x on the interval from 0 to 4. So, okay, it just clicked. I think B is false. And the reason being is that the question states that which of the following could be false. It's saying could be false. This could be false because in the directions or in the problem, it says select values of a continuous function f are given in the table. Now the thing is about A, C, and D is that the intermediate value theorem and the extreme value theorem the only condition for those is that the function needs to be closed and the function needs to be continuous on a closed interval. But the mean value theorem is different, where that it not only has to be continuous, but it also has to be differentiable. And so this could be false depending on if the function f is differentiable, but it doesn't say that the function f is differentiable. It only says that the function f is continuous. And so it's got to be B. So, yeah. Okay, jump to 8. Let f be the function defined by f of x is equal to which of the following statements is true? Okay. So we have f of x is equal to 3x to the third minus 36x plus 6 from negative 4 is less than x is less than 4. Which of the following statements is true? F is decreasing on an interval. F is okay, so what we're trying to figure out is where it looks like based off of the answers, we're trying to see where f is decreasing. So if we're going to see where f is decreasing, we need the derivative. So f prime is going to be 9x squared minus 36. I'm going to set that equal to 0. So 9x squared is going to be equal to 36. Divide by 9, x squared is going to be equal to 4. Take the square root, x is going to be equal to plus or minus 2. So the interval that we're looking at is from negative 4 to 4. And we have zeros. So the graph is going to cross at negative 2 and at 2. Now, I'm just going to, instead of testing values, I can just already tell that this right here is a cubic function. So that, oh, wait a minute. Wait a minute, I didn't find the zeros here. I found the zeros here. Okay, no. Yeah, sorry. This is a quadratic function. So here's the quadratic function right here. Okay, and I can see that f prime is negative from negative 2 to 2. So f prime is positive here, negative here, positive here, which makes sense because our function is cubic, meaning that it's going to be increasing, then it's going to be decreasing, then increasing. So this is what the function is going to look like. The function f is going to be increasing from 0 to negative 2, and from 2 to, or that's where it's going to be increasing, 2 to infinity, and we're decreasing here where f prime is negative. And so that's got to be D. Okay, so for 9, let f be the function defined by, so So f of x is equal to x to the third over 3 minus x squared over 2 minus 6x, on which open intervals is f decreasing. Okay, so we're doing the same thing. We're looking for decreasing, so we're going to find f prime of x, which would be equal to x squared minus x minus 6. Set that equal to 0. I'm going to factor this into x minus 3 and x plus 2. So x is equal to 3 and x is equal to negative 2. So making a number line, so x equals negative 2 and x equals 3. So f prime is a quadratic just like it was before, and it looks like this right here. So if I were to graph f prime, it's going to be negative here, positive here, positive here. This is for f prime of x, okay? And so where is it decreasing? Between negative 2 and 3 only. So A. All right. Okay, and that should be everything for this progress check.